Good morning, everyone. My name is Nidhi Yadav, and my topic for presentation is forces in three dimensions. Null lines and null planes. Null lines of a given system of forces, referred to O dash as origin, are the lines about which the moment of the system vanishes. The plane containing all the null lines are known as null planes at the origin O. The point is known as null point. Equation of null plane is given in the determinant form xyz abc capital xyz is equals to lx minus a plus my minus b and nz minus c in determinant form. Equation of null plane in vector form is given by vector r dot vector s dot vector g is equals to r cross s into vector r. Points or central axis. A system of forces acting at different points of a rigid body can be reduced to a single force of magnitude r acting along a line and a single couple of moment g cos theta about the same line. This same line is called the points of central axis. Central axis. A given system of forces acting on a body can be reduced to a force together with a couple whose axes coincide with the direction of the force. Or every given system of forces acting on a rigid body can be reduced to a wrench. Now, what is wrench and pitch? If a system of forces can be reduced to a single force R and the couple having moment K whose axis coincide with the direction of the force, then R comma K is called the wrench of the system. Here R is called the intensity of the wrench and the ratio K upon R is called the pitch of the system. Screw. A straight line along with the acting force when considered together with the pitch is known as a screw. A screw is a definite straight line for a definite pitch. For a rigid body to be in equilibrium, R is equal to 0 and G is equal to 0. Condition that a general system of forces can reduce to a single force in space. We know that a system of forces acting on a rigid body can be reduced to a single force R acting at some arbitrary point O with a couple having moment G. Let theta be the angle and the direction of force OA and the axis of couple OP. If x, y, z are components of the forces are along direction axis coordinate axis L, M, and N, and the component of G, then the direction cosines of the lines OA are x upon r, y upon r, and z upon r, and the direction cosines of the lines OP are L upon G and M upon G and N upon G. Then cos theta is equal to Lx plus My plus Nz upon Rg implies Lx plus My is equals to Rg cos theta. If theta is equals to pi by 2, then Lx plus My plus Nz is equals to 0. Now, what is invariant quantities? The quantities Lx plus My plus Nz and x square plus y square are invariants for a given system of forces, whatever be the origin and axis. R square is equals to x square plus y square plus z square, and g square is equals to L square plus M square plus N square. The direction cosines of the direction of force are x upon r, y upon r, and z upon r, and the axis of couple having direction cosines L upon g, N upon g, and M upon g. The angle between the two can be given by cos theta is equal to Lx plus My plus Nz upon Gr implies Lx plus My plus Nz equals to G cos theta upon R square. Invariance of R means x root of x square plus y square plus z square, and invariance of g cos theta means Lx plus My plus Nz upon R. Pitch P is given by k upon r, which is equals to g cos theta upon r, which is equals to Lx plus My plus Nz upon my R square. Now, few question answers related to this theoretical presentation. The necessary and sufficient condition for a system of forces to reduce a single resultant force are g vector g dot r is equals to 0. Vector equation of central axis is g minus r cross r is equals to pr. If R and G be the dynamic of the system of forces acting on a rigid body, then the system will be in equilibrium if R equals to 0 and G is equals to 0. If the two forces P and Q are such that their central axis is given in position of the line of action P, then the locus of action of Q is a conicoid. If the next, if at all the point on a given straight line are drawn the axis of principal moment corresponding to any given system of forces, then the axis lie on a hyperbolic paraboloid. Dash is a combination of force and couple, which is wrench. The line of action of conjugate forces are called dash lines, conjugate lines. Any wrench may be resolved into two Wrenches whose dash is an infinite number of ways, that is right angles. Thank you for thank you for listening me.